Good afternoon, everyone, and thank you for attending our How to Unobsolete Your Legacy Keypad Design webinar. My name is Ryan Woods, a Content Marketing Manager here at Epic. Before we get started, I just want to let you all know that you'll be muted during the presentation. If you have any questions as we move along, please enter them into the questions panel, which is located in the webinar control panel, and we will try to get to them all at the end of the presentation. If we don't have time to go through all of your questions, we'll be sure to reply to you by email. Also, we will be recording this webinar and posting both the recording and the slides on our website and YouTube channel. Our presenter today is Stephen Goodman, our User Interface and Cable Assembly Product Manager. Stephen is a mechanical engineer with a Bachelor of Science and MBA from Northeastern. As the User Interface and Cable Assembly Product Manager here at Epic, Stephen works closely with customers to provide solutions to specific problems during design consultation, and where needed, helping with the creation of specific designs. So without further ado, I will pass it on over to Stephen.
Thank you, Ryan. Good afternoon, everyone. Again, my name is Steve Goodman, and I'm one of the product managers here with Epic. Today, we're going to be talking a bit about options to deal with obsolescence in your legacy keypad design and ways we can help you hopefully unobsolete said legacy keypad design. So first, we're going to talk a bit about why these keypads and HMIs go obsolete. We'll talk a bit about some candidate technologies that we can support and ways we can go address the obsolescence risk. Next, we'll touch on the actual steps we go through to recreate your design. And then, if there is interest in moving forward with a new project, we'll talk through the specific individual steps and actions we need to go take to get you moving forward. Lastly, we'll have a brief Q&A, and that'll conclude today's webinar. So first, talk a little bit about why keypads and HMIs go obsolete. So there's a lot of reasons for this. But first, what do we mean by obsolescence? That specifically entails the process of something going obsolete or outdated. And again, this could be market conditions, or could be technological advancements, there could be compatibility concerns, or there could be just soft demand for a certain product. A lot of those reasons will drive a product to go obsolete. And it's not just electronics, it's all items, it's all things. It's not just our electronic products we make here at Epic, it's not the electronics that you're probably dealing with. Again, these are all items that deal with obsolescence. Sometimes obsolescence is planned, it's intentional, and it's done to help make other products more profitable, or to actually improve challenges that engineers and designers may face over the course of developing products. And lastly, one thing we may see common in the industry is this EOL terminology. That's another way that we indicate product is going end of life. And again, this is wildly common in the electronics industry. If you've been through this and you've been lucky enough to find a product that has been superseded, then the good news is there may be a replacement. It's just going to have a different part number. It may have a different revision. It may be form, fit, function identical. But the good news, if an item is superseded, there's generally a hope for something else to be used as a replacement part. But that's not always the case. Some items will just go obsolete with no exact replacement available. And even when they do go obsolete, it's important to note that that's denoted by the original equipment manufacturer. There may still be thousands, tens of thousands, or even more parts in distribution, even though the item is obsolete. This can be a bit challenging as you go develop and build new parts, but the important takeaway here is any new design, any BOM, anything that we're reviewing for a new electronic item, we want to do an obsolescence review and make sure that we're not speccing in an item that is obsolete. And if there is obsolescence risk with a certain item, it's a good idea to take a snapshot of the current industry and current stocking distributors levels This particular example that we pulled from one of the major online electronics distributors shows a pretty standard 3-position connector that is obsolete. However, they have over 71,000 of these in stock. The point is, this is a risk that needs to be flagged, but not one that we need to dump a tremendous amount of resources into in the short term. It's more of a long-term planning because there is sufficient stock for this particular connector. So again, this is important because when you have a product that you need to find and you cannot find a source, you're stuck. There's a lot of companies out there that may be building a product and may expect to be a going concern, but because of whatever financial hardships or market conditions, they may go out of business or shed product lines and walk away from contracts because of profitability and manufacturing concerns. If that's the case, obsolescence will impact whomever is involved with that supply chain. This is also important for products where there's no aftermarket. If the gasket on your freezer in your home is not working properly, it's a lot easier to go get a $50 or $100 gasket and replace it instead of buying a brand new refrigerator for your kitchen. Some industries, this aftermarket doesn't exist. So if you invest in an expensive piece of medical equipment and the buttons start to wear, and the original OEM who developed that piece of equipment is unable to give you replacement parts, what are your options? This is really important because over 600,000 businesses per year in the US fail or go out of business or have some other kind of financial hardship. And in doing so, putting a stress and strain on the associated supply chains. This is especially important for our military and aerospace industries. For a lot of these products, the expected service life can be over 50 years. Replacements will be necessary. Even the best engineers, products, and materials can design keypads, buttons, touchscreens to work, but for them to work at the requirements they must for 50 years can be a challenge. That's why there's so many options available for military and aerospace aftermarket and spares. The government intentionally funds a lot of the tier ones and OEMs in this market to go develop spares contracts because they know if a certain cable harness breaks down over time, the rest of the UUT may be inoperable. So there's a tremendous amount of proactive effort done to address obsolescence risk, especially in the military and aerospace markets. The last key takeaway here when dealing with these types of complex electronic items is the fact that there's typically extensive testing involved and necessary for any replacement item. Above and beyond, it's not guaranteed that a true drop-in replacement can even be made. Some of the items here on the screen may contain specialty PCBA components that have high minimum order quantities that make it cost inhibitive to go and develop a new solution using one of them. For all of these reasons, tremendous amounts of care, energy, and focus need to be spent for any new replacement project dealing with obsolescence. So what are some of the technologies that we at Epic can help support? So the general rule of thumb that we follow here is to review the given candidate technology and determine, does it have buttons? Is there an LCD display? Are there LEDs or maybe a touchscreen? And if there are, the odds are we have a solution to help. The specific products that we can support here at Epic cover a range of HMI and keypad technologies, from compression molded silicone elastomer to membrane switches made of polyester or flexible polyimide circuits, machined avionics bezels, 19-inch LRU front panels, and the full gauntlet of cap touch and resistive touch type touchscreen assemblies. Among the simplest of the technologies that we can support are low complexity graphic overlays or dead front panels. These are really just glorified stickers. They typically have an adhesive backing, typically called a PSA, for pressure sensitive adhesive. On the front, they're typically a hard-coated plastic sticker, if you will, made of either polyester or polycarbonate, but they're screen printed and sometimes have different holes and other features that allow light to pass through. But these low complexity items are very simple for us to reproduce. We just need a little bit of information from our customers to go help reproduce these types of items. Another low complexity technology that we support, again, is our compression molded silicone elastomer keypads. These are typically made of a variety of grades of silicone. Among them, we can support traditional industrial grade silicone, transparent and translucent silicone for backlighting requirements. We can perform laser etch and other complex processes to make the keypad perform, to make it backlit properly, and to add markings, text, and other icons throughout. These are all hard tooled items. There is a little bit of engineering and NRE costs that are needed upfront to develop this type of solution. But if there is sufficient samples or other information available, Epic can reproduce these without an issue. In addition to just a bare rubber keypad or silicone rubber button, we can pair these with a dome switch assembly, hard keycaps, and other membrane switch technologies to go make this from just a simple elastomeric item to a fully functioning electronic switch assembly. Moving up in complexity, we have our membrane switch and our bare PCB membrane switch technologies, which are really just pairing the previous two technologies we talked about, which is a graphic overlay laminated to a flexible circuit with some buttons or switches on it. With these types of switch technologies, the majority of them use either surface mounted tactile switches or these convex dome switches made of stainless steel. These are extremely high reliability and relatively simple technologies, but with some tricks and nuances to their assembly and test. For Epic to reproduce any of these items here, we would need, at the very least, a preliminary drawing that shows the rough dimensions and how you want the switch to function, any artwork that's available, and some initial performance or schematic requirements for us to work with. The flexible circuit of a membrane switch is a very simple design. Just as simple as using a rigid PCB to replace the flexible circuit with all things equal. And there's several reasons to consider a rigid PCBA, but ultimately both are considered a medium technology type of product for us to support. Epic also supports a wide range of injection molded items. While the products themselves are simple, the actual process to tool up, mold, and yield a good part is a bit more complex. Some of the most common products that we reverse engineer and manufacture are single individual keys or buttons that are hard tooled and made of some injection molded plastic. Others include enclosures like a clamshell type enclosure or some kind of housing with a lid and potentially a gasket. But again, Epic has the ability to go develop, design, and create these from scratch. So if you're trying to recreate a certain solution, it's not always clear if we need to match that 100% or can we develop a new enclosure that will fit whatever widget we're trying to contain and protect. Some of the most common materials we work with include ABS, polycarbonate, polypropylene, and other thermoplastics. We typically use brand name injection molded materials. Covestro and Savic are two of the most common that we work with, but there's also a number of lower cost, readily available house brand materials that we can use for more generic compounds like polycarbonate and such. We always want to know what you're doing with this product, where it's going, what requirements you have, so we can analyze the material that we're recommending and make certain that this aligns with all of your program objectives. Moving a bit further down the complexity scale, you have these mechanical assemblies that include electronic items, switches, screens, etc. These can range from using off-the-shelf displays to actually creating a custom display assembly. Many of these have mil-spec guidance and requirements within them that we must comply with. A lot of our avionics bezels and other front panel type projects are at obsolescence risk because just the number of components and off-the-shelf items that are used to create them. Some of the other things that we find with our customers are that over time, some technologies will actually become less prevalent and less common by the original equipment manufacturers, so that over time, we see less and less backlighting by certain technologies. That becomes a challenge when we're trying to recreate a design because maybe a 40-year-old backlighting technology doesn't exist anymore. So additional redesign efforts must be taken to go through and produce a good part. Next, we'll talk a little bit about the actual steps we go through to recreate your design. So again, it's clear that the numerous core products and different technologies that Epic has at our fingertips allow us to be a high value, quick, and low cost solution for our customers. Epic has a number of core technologies that we support that range from circuit boards to machine parts to compression molded rubber to off-the-shelf and custom LCD displays, gasketing, and all the items that go in between. Because these are all core competencies, because we're experts in all of these, we have an existing supply chain. We can support you in what you're trying to do real time with design for manufacturability, so that if you are trying to reproduce a part and you are looking to assess the form, fit, function, impact of a reverse engineered new widget, we're in a position to be able to give you high confidence, real-time answers to help you make decisions and get to market faster. So some of the specific things we do are to take a sample or to take a drawing, take any information that you have that you're trying to recreate and use our resources, tools, and expertise here. At our corporate headquarters here in New Bedford, Massachusetts, we have several in-house test and measurement systems and devices that we can use to help recreate your part. So for some of the higher complexity machined bezels, injection molded items, and other things, we can use our CMM and our optical comparator to get the dimensional information and dimensional data that we need to reproduce that part. If there's a cable harness that is attached to your front panel, we have full line of electrical test capabilities here that help flush out any potential wiring or pin-out concerns. We also have a series of mechanical type equipment for testing to try to assess the performance and materials used in some of these builds. Lastly, and most importantly, we have a full line of environmental test chambers here at Epic that we can use once we have a reverse engineered item built. We can stress it and subject it to high temperatures, low temperatures, and even thermal shock through temperature cycling to go and make sure that our replacement item will meet the requirements that you're trying to solve. So once we have a sample or some data from our customers, and then we've gone through the motions of analyzing it and testing it and measuring it, the next step is for us to actually recreate that item digitally using our CAD and solid modeling software. So we typically use SolidWorks for everything. We also use Altium for our boards and PCBA design. But through these software and our expertise, we spend a lot of energy working with our customers to develop the documentation that is necessary to go recreate these parts. It's important to note, making a drawing isn't just for us at Epic. We obviously need this to make the part, but making a drawing like this is just important for you, our customer, so that we can clearly define with dimensions and tolerances and materials and a bill of materials. So we can clearly define what we're building, how we're building it, to make sure it meets all of your expectations. This is inherent in our process, creating a two-dimensional drawing and sending it to you, our customer, for review and approval. We do this at the beginning of the project, right before we tool up and invest in hard tooling or any other equipment we need to reproduce your part. We have a number of manufacturing processes that we use to recreate these items. Some of the more interesting, if you will, would be our compression molding and die cut processes. So both of these involve an initial investment in both the development of drawings as well as an initial investment in hard tooling to go recreate the parts. While die cutting is much, much less expensive in terms of tooling investments, compression molded silicone is a wildly low cost process once the tool is developed. A big reason for that is some of these compression molded tools we can design with multi-cavities so that every shot we yield numerous or dozens of parts. So depending on the technology that you're trying to reproduce, we have a number of core competencies and technologies at our fingertips to use. In addition to everything we do with compression molding, we also injection mold our overmolded cables. A lot of these electronic devices have some type of overmolding. Most of them use a thermoplastic like PVC or TPE, but these are all custom, purely custom. And what I mean by that is we can literally add anything to your design that you want. This can include company logos, polarity markings, other specs and rating information like the current or wattage, or it can just include branding information. All right, next we'll talk a little bit about some steps to move forward with a new project. So before taking the first steps with a new design, it's important to understand the application, where this product is going, where it's going to be used, how it will be used. This is important because if there is a unique use case, such as high temperature or biocompatibility, or some unique requirement to do with a military or aerospace specification, we need to know that. We ask for our customers to help better define and help work with us to determine if any special materials are needed. It's also important to carefully review the available documentation, drawings, the data that you have. There's numerous instances where we've worked with a customer and all they have are samples. We need those samples. We are going to take them, we're going to destroy them, and use them to create the engineering data, drawings, and manufacturing plan. With that said, any new part like this is going to have some NRE to go recreate it. Whether it's a simple die cut overlay, where NREs could be a few $100s, to a custom membrane switch with a touchscreen panel, where NREs could be a couple $1,000s, to a full front panel that's qualified to mil standard A10, where NREs could be tens to even hundreds of thousands of dollars. You must be prepared to invest in tooling to recreate a lot of these parts. Lastly, and most importantly, we always suggest that you plan for at least one design iteration. So that's important because all of these products are effectively a guess and check. You're coming to us to try to make something that we have never made before, and we're using all the available resources and information at our fingertips to try to recreate that. But the fact is, we can have all the information available, and it may not be actually what you want. So we always suggest to plan for at least one design iteration. That way, we can tool up, build, get you your parts, and you can try them out. You can test them, you can do fit checks, and then from there, we can make any fine tune or any last minute adjustments we need for the project to be successful. As we stated earlier, we always make a drawing. This is inherent in our process. But before we jump into this, we want to work with you and have a conversation. Do you already have drawings? If there's existing drawings, do they match what you want? Do you want to make changes upon what you already have? The other reason that we always make a drawing is because it helps us document any critical requirements or dimensions or materials. And we use this as a mechanism to communicate with our customers so that there's no surprises, so that we can get to market faster and that we're not scrapping or wasting parts because there's a miscommunication about the material or color or tolerance associated with a given part. In addition to always making a drawing, we use SolidWorks to create a step model and other three-dimensional files to share with our customers so that you can drop this file in your model and do a live fit check. So if you are going to move forward, we utilize the EPIC inquiry forms shown here that help us capture all the relevant information early and get that information up front. And then this helps us really get a complete, comprehensive quote back to you as quick as possible. I'm going to wrap things up with our summary here. Again, EPIC has a tremendous amount of capabilities, resources, and technical expertise. However, we need some type of information or samples to work with. We're a vertically integrated, privately owned company, and we literally own our own supply chain. This helps us get to market faster with less risk and helps give you, our customer, real-time design feedback. We can help design and develop the entire product, starting from the initial concept to the actual product itself, to all the tooling and manufacturing equipment that's needed to reproduce your keypad and other product. And lastly, once we have completed this and shipped a good part and everybody's happy, Once this moves into production, we have the ability to stock finished goods here in our New Bedford, Massachusetts corporate headquarters, keeping finished goods here in stock and allowing you to pull from inventory instead of having to wait 4, 6, 10 weeks every time you want to make a pull from inventory. So with that said, I'm going to kick it over to Ryan now, who's going to talk a bit about our other products here at Epic.
Thank you, Stephen. While he reviews the questions that came in, I want to briefly mention some of the additional products we offer here at Epic. For more than 70 years, Epic has designed and manufactured custom built-to-print electronics. Our expertise not only lies in printed circuit boards, but also custom battery packs, flex and rigid flex PCBs, overmolded and other types of cable assemblies, CNC machining through our sister company Metalcraft Machining, high reliability user interfaces, flexible heaters, and energy efficient fans and motors. Next slide, please. And I'll turn it back over to Stephen to go through some of the questions that came in.
Thank you, Ryan. All right, I'm going to read a couple of the questions we have here and try to answer them for everybody. First question is, I'm not sure what material these buttons I have are made of. Is this an issue? So no, this is not an issue, but we would love to work to better understand any requirements and application information about these buttons. If you have samples that you can send to us, we can review and study those samples to try to determine what kind of material it is, or we can help recommend something. So it's not an issue, but we need to work with you in some way, shape, or form to get to some agreement on what that material needs to be if you don't have any information on it. Next question here is, we need 100 to 500 pieces made. Is this quantity okay for your processes? Yeah, 100 pieces is no problem. 500 pieces is no problem. We're really a high mix, low volume company, so that is a great fit for us. Our sweet spot is anywhere from 50 to 50,000 pieces, and obviously 50,000 is a huge number for some military contracts, versus 250 is a very small quantity for some industrial product applications. But I guess everything's relative when it comes to quantities. But that's no problem for us. Really what it comes down to is, are you willing to invest in the tooling that's needed? And then based on the quantities you're trying to make and what the product is, some tooling can be more expensive, but it produces a lower unit cost. And what I mean by that is, earlier in the presentation here showed a slide of a compression mold, and you saw the number of cavities in it. The more cavities, the higher the initial tooling expense, but the lower the unit cost. So basically, if we know the quantity you're trying to make and your approximate cost targets, we can work with you to develop a plan to quote 100 to 500 or even more quantities. Next question is, can you quote a keypad if all we have is a physical sample, no drawings? Yeah, I touched on that earlier in the presentation here. Basically, that if we have a physical sample, that's one of the best things, the most important things for us to be successful. We don't necessarily need drawings. They are helpful, especially if there's features or interface dimensions that are critical. But getting a physical part is among the most beneficial items for us to be successful here. I should note actually that if we do use a physical sample to recreate a design, we're probably going to destroy it. We're going to take it and section it or cut it apart to better understand how it was built and some of the nuances of how to make it. Another question here is, how do you test for long-term reliability, especially in harsh environments? That's a good question. It's a bit open based on the technology, but in terms of long-term reliability, really what we try to do is utilize materials and off-the-shelf items and components that are reliable, that are high fidelity, and are ones that we can use and have confidence in. For example, we solely use dome switches made of stainless steel. We do not use polydomes. We do not use domes made of other non-metallic materials. And the reason is because dome switches are not expensive, but they're a critical part of the assembly. And we believe using a high fidelity dome switch is well worth the small costs that you need to pay above and beyond some of the lesser expensive carbonate type technologies or polydome technologies. So how do we test for this? We'll set up a jig and do cycle testing. We'll use our ESS chambers and other thermal chambers to run thermal shock, temperature cycling, and other testing to stress a device. We'll set up a little counter and a little pneumatic piston to go press a button 100,000 times and make sure that it's still falling into the in spec for switch bounce. So it really depends on the technology, but there's a lot of options that we have to test for long-term reliability. We've got time for one more question here. It's, do you support fiber optic backlighting panels, and how much would something like this cost? Unfortunately, we don't support fiber optic backlighting panels, largely because that technology is obsolete. We don't support that. But instead, what we do is, instead of using a fiber optic method to backlight the panel, we'll actually use other technologies. One of which is using discrete LEDs and some kind of light guide film or light guide panel, or just individual LEDs with different films and diffuser layers to go act as that backlight, replacing the fiber optic. So unfortunately, we don't have a capability for fiber optic backlighting. So it's tough for me to estimate what something like that would cost. That is all the time we have. I want to thank you for attending our webinar. Have a great afternoon.